Hello everyone, I am Kirtana, currently pursuing my BE in Electronics and Communication at Sri Venkateshwara College of Engineering, Bangalore. Today, I am here to present you all a topic of chemistry that is corrosion and its control. In today's presentation, I will be presenting you about the definition of corrosion, types of corrosion, methods to prevent corrosion. Moving on to the main topic, that is the definition of corrosion. Corrosion can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. Example, rusting of iron, a reddish brown scale formation on iron objects. The reaction is when iron combines with two hydroxide ions gives ferric hydroxide. Further, ferric hydroxide combines with oxygen and water which gives hydrated ferric oxide, that is the formation of rust. Now let's move on to the next, that is the types of corrosion. There are two different types of corrosion, differential metal corrosion and differential aeration corrosion. So the first one is differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with one another and exposed to a corrosive environment or a corrosive medium. The metal with the lower electrode potential acts as anode, undergoes oxidation and gets corroded easily. The other metal with higher electrode potential acts as cathode, undergoes reduction and is protected from the corrosion. The rate of corrosion depends mainly on the difference in the electrode potential between the two metals. Higher the difference, faster the rate of reaction. Examples of differential metal corrosion is tin coating on copper vessel, steel pipe connected to a copper plating or copper plumbing, bolts and nuts made of different metals. Next one is differential aeration corrosion. When a metal is exposed to different concentration of oxygen or air, the part of metal exposed to the lower concentration of oxygen becomes anodic and undergoes corrosion. The other part of the metal exposed to the higher concentration of oxygen becomes cathodic and remains unaffected. Example, iron rod partially immersed undergoes corrosion, but the exposed part does not undergo corrosion and is unaffected. Here, the iron rod which is immersed and it is exposed to the low concentration of oxygen gets corroded easily, and the part which is exposed to the higher concentration of oxygen is unaffected. And the cathodic and anodic reactions are as follows. Now let's move on to the types of aeration corrosion. In aeration corrosion there are two types, that is waterline corrosion and pitting corrosion. Waterline corrosion. It is observed in iron or steel water tanks partially filled with water. A distant brown line is formed just below the water line due to the deposition of rust. In this picture, we can observe that the pillars of the building which is inside the water are corroded and the pillars which are above the water line are unaffected, because the pillars which are inside the water line, it is exposed to the lower concentration of oxygen and is corroded. The other part which is exposed to the higher concentration is unaffected. And the other example of waterline corrosion is the bottom of the ships which is submerged for a long period of time in the water. The next type of aeration corrosion is spitting corrosion. This type of corrosion is observed when dust particles or iron droplets deposited over the metal surface. The less aerated area becomes anodic and undergoes corrosion and form a pit, whereas the other part remains unaffected. Now let's look into the methods to prevent the corrosion. The first one is protective coating. Corrosion is prevented by the application of protective coating on the metal surface, thereby the metal surface is isolated from the corrosive environment. Galvanization is one of the method of protective coating. What is galvanization? The process of coating zinc on the base metal, that is iron or steel surface, by hot dipping is known as galvanization. The galvanization process is carried out as follows. The metal surface is first washed with the organic solvent, that is benzene or toluene, to remove the organic matters. The metal surface is treated with dilute H2SO4 to remove other deposits. Then the metal is well washed with water and is air dried with a hot air. The metal is treated with a mixture of ammonium chloride and zinc chloride solution which prevents the oxidation of the coated metal. Then the metal is dipped in a mixture of zinc chloride and ammonium chloride. Then the metal is dipped in a molten zinc at 4500 degrees Celsius. Excess of zinc on the surface is removed by passing a pair of hot rollers which removes excess of zinc and produce a thin coating. Here the figure shows the different steps involved in the galvanization process. Application of galvanization process is galvanized materials are used in fencing wires, buckets, bolts, nuts, screws, etc. The second method is cathodic protection. In cathodic protection, sacrificial anode method is one of the method of cathodic protection. Sacrificial anode method involves the use of a metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to more anodic metal using a metallic wire. More active metal gets corroded while the parent metallic structure is protected from the corrosion. Example, when steel metal is to be protected, it may be connected to a block of magnesium or zinc. In such a case, steel acts as cathode and is unaffected. Magnesium or zinc acts as anode and undergoes sacrificial corrosion. When the sacrificial anode gets exhausted, it is replaced with the new ones. The most commonly used sacrificial anodes are magnesium, aluminium, zinc and their alloys. This is used in the protection of ship's hull by fixing zinc plates. Protection of an underground pipeline with a magnesium anode. Here in this picture we can observe that the iron pipe which acts as cathode is connected to a magnesium block which acts as anode. Thank you for watching.